Welcome to another session of switching power supply repair training. In the previous session, you learned about the components of a switching circuit and which part of the power circuit is includes. In this session, we want to discuss troubleshooting and its solution and teach you. The prerequisite for switching power supply repairs is a complete familiarity with electronics and components. So if you are familiar with electronics, be sure to focus on repairs to learn better. Otherwise, start by learning electronics even at the basic level. Here you can see an overview of the power board. In this section, these two transistors are switching transistors. In this image, you can see some diodes, resistors, and capacitors. Behind each transistor, there is also a diode. The resistors here act as fuse resistors. If these transistors burn out or generate excessive heat, causing excessive current flow, these resistors burn out and cut off the transistor's power, preventing the transistor from suffering further damage, even protecting neighboring transistors. So these two transistors are switching transistors and are very similar to each other. Even in 80% of cases, the same type of transistor is used for this part. Here we have two transistors with the number 13007. This number is used in about 60% of powers. If there were another number, both transistors would have the same number. After the transistors, we have two capacitors. These capacitors act as start capacitors and play an important role. If these capacitors become damaged, one of the signs is that the power works for a while after being turned on but then suddenly turns off. So if the switching power supply suddenly turns off, the first suspicion should be directed towards these capacitors, and they should be checked and replaced. These capacitors have values such as 1 or 2.2 or 4.4 or even 10 microfarads, but their voltage should be 50 volts. These two capacitors are exactly the same and their values are identical. In some cases, when the power does not turn on, the fuse present here is burnt. In some powers, there is also a coil and capacitor in this area that filter the frequency or electricity. These components are not important, only the fuse is important. If the fuse is burnt, do not quickly replace the fuse, because in this part of the circuit, there are definitely connections that have caused the fuse to burn. In such situation, first test the diode bridge. If the diode bridge is intact, move on to the transistors and diodes around them and test them. They may be burnt. If the transistors and diodes are intact, move on to the Zener diodes here and test them. In general, when you see that the fuse of power is burnt, first connect the power to a test lamp. And if it does not turn on, it means that the diodes behind the transistors or the Zener diodes are burnt. But if the test lamp turns on, besides the burnt fuse, one of the transistors or both of them are burnt and need to be replaced. So before replacing the fuse, if the test lamp turns on, check and replace the transistors. The point to note is that if a transistor is burnt, definitely replace the diodes behind it and the resistor in front of it, which you can see here. Because the component that burns also damages the components around it. But always test the diode bridge first, because in most cases, there is a short circuit and the diode bridge is burned while the transistor circuit is intact. When you replace diode bridge, the fuse will no longer burn and the test lamp will turn off. But if diode bridge is fine, the problem lies with the transistors. However, sometimes the power supply does not turn on and all the components mentioned are fine. What should be done in this case? In this situation, you need to check the voltage using the green wire test. The green wire must definitely have a positive 5 volts. If this wire does not show 5 volts positive and the power supply does not turn on, the reason is that this IC is faulty. Of course, it's better to test it this way. That means if you see the power supply does not turn on, has no connection, and the fuse is not burnt, then you should proceed as follows. First, check the voltage on the purple wire. If it has 5 volts, it means that the standby circuit is fine. Then move on the green wire. If you notice that the purple wire has voltage but the green wire doesn't, it means that the IC is burnt and you need to replace it. But if both of the green and purple wires have 5 volts and the power supply still doesn't start, you must definitely check these 2 transistors present here. As mentioned in the previous session, these 2 transistors may be here or near this transformer. So you should replace the transistors. Because this IC commands the transistors and these 2 transistors send the command to this transformer in the form of oscillating electricity, and this transformer starts up these 2 transistors. Therefore, even if one of the 2 transistors is faulty, the IC does not send the command to the transformer, and the switching operation doesn't take place. Now again, if replacing the transistor does not turn on the power supply, you still need to test these 2 transistors placed here. One or both of them may be burnt. The burning of these transistors, which are switching transistors, doesn't necessarily create a connection issue. They may have been cut off internally, meaning the connections between the pins are served. If you find that 2 transistors are fine and this IC is also fine and these 2 transistors are fine too, but still the power supply does not turn on, the reason is the malfunction of this transformer and optocoupler placed here. Now, how do we know if the transformer and optocoupler are faulty? The testing method has been taught before, but the best way is to replace the same transformer or a similar one. However, try to replace the optocoupler before the transformer. So first, replace the optocoupler. If the power turns on, it means the problem has been resolved. Otherwise, if all transistor and IC are fine, you need to replace the transformer. This transformer located in the middle often gets damaged. Unlike the 2 transistors above and below, it doesn't usually have many issues. So when you are sure about health of the other components, be sure to replace this transformer. Keep in mind, you must first ensure the health of the optocoupler before moving on to the transformer, because the optocoupler establishes the connection between the primary and secondary circuits. And one of the best ways to test the optocoupler is to replace it. Here you have learned one of the troubleshooting methods and understood what reason might be if a power supply doesn't start and which components need to be checked and replaced. In the next session, we will continue testing about power supply troubleshooting. Thank you for watching. Please give me a thumbs up and please share this video to who likes learn about the electronics and how to fix switching power supply. So to the next video, take care, see you soon, and bye bye.